Usually massive sound systems mean like towering speaker stacks at a rock concert. But today we are decoding the architectural audio ninjas hiding right above your head.
Yeah, it's a completely different world of audio.
Right. So our mission in this deep dive is to unpack a highly detailed product page from HDTVSupply. It is for a pair of QSC AcousticDesign ceiling loudspeakers.
And at $650 a pair, these are definitely not for your living room.
Oh, absolutely not. These are engineered for demanding public spaces, like airports, restaurants, train stations, places like that.
Exactly. Because to fill those massive, noisy spaces, you can't just, scale up a home stereo. It requires highly specific acoustic hardware.
Right. So inside these ceiling units, we're looking at a two-way system.
Yeah, there is a 6.5-inch weather-treated paper cone woofer and then a 0.75-inch aluminum dome tweeter.
Right, hold on. Paper for the woofer and aluminum for the tweeter. That feels like a really random mix of materials to throw into a high-end commercial device.
It sounds weird, I know, but it actually comes down to the physical properties of sound waves. Low frequencies from a woofer need a material that is lightweight but flexible to push a massive amount of air.
Ah, so hence the paper.
Right. But in a commercial space with open doors or HVAC humidity, standard paper would just rot. So it has to be weather treated.
Makes sense. And what about the aluminum?
Well, the tweeter is handling high frequencies, up to 20 kilohertz. It needs to vibrate incredibly fast without warping or distorting, which is why they use highly rigid aluminum.
Okay, I get that. Now, the specs also highlight a 135-degree DMT waveguide, pushing out like a max SPL of 112 decibels.
Yeah, that 135-degree coverage is crucial.
I am picturing it like a wide-angle lens on a camera, right? Like bathing the whole room evenly instead of a narrow spotlight of sound.
That is a perfect analogy. The waveguide is basically a precisely engineered physical contour, almost like a funnel sitting around the tweeter.
Because high frequencies naturally want to beam straight out like a laser pointer?
Exactly. The DMT waveguide physically catches and shapes that high-frequency acoustic energy, spreading it outward to match the dispersion angle of the woofer.
So whether you are directly underneath the speaker or, say, 20 feet to the side, the audio volume and clarity remain completely seamless.
Right. But pushing that much consistent sound across a massive airport terminal creates a completely different physical problem.
The wiring, I mean, if I tried to run 50 speakers on a single line for my home theater, my receiver would literally catch fire.
Oh, absolutely would. Standard home systems use a low-voltage 16-ohm setup. If you run a wire for hundreds of feet like that, the natural resistance in the copper wire just eats the power.
Resulting in massive signal degradation, I assume. So how do installers daisy-chain dozens of these across a huge building?
To bypass that physics problem, these QSC units include a 70 or 100-volt multi-tap transformer.
Let's unpack that. Are we talking about high-voltage transmission lines, like the power grid?
It's a very similar concept, actually. Think of it like a municipal water system. You pump water from the tower at incredibly high pressure.
And that pressure is the 70 or 100 volts.
You got it. That high pressure lets it travel for miles without losing momentum. Then, at every individual house, a valve steps that pressure down to a safe, usable flow.
Oh, wow. So the multi-tap transformer on each speaker lets installers step down that high-voltage audio signal.
Exactly. They can set it to draw anywhere from 7.5 to 60 watts, or even bypass it for 16 ohms. It completely eliminates signal loss over long distances.
That is wild. And amazingly, all of that heavy-duty electrical infrastructure is designed to be completely invisible.
Yeah, the physical design is really slick.
The specs detail the zero-bezel, snap-fit magnetic grille that you can paint over to match any ceiling tile decor. It just blends right into the architecture.
It really does.
Yeah.
But speaking of specs, did you catch that bizarre contradiction in the source material?
Oh my gosh, the feature list anomaly. It is so funny.
Right. We are looking at an elegant, flush-mounted ceiling speaker.
But then the features list suddenly advertises a 3,000-watt amplifier, a powered 12-inch subwoofer, Bluetooth streaming, and a 32-inch speaker pull for DJs.
Yeah, someone definitely pasted the specs for a heavy-duty, portable DJ PA system right into the middle of the ceiling speaker's retail page.
It's the classic copy-paste error on a massive distributor site. I would pay good money to watch an installer try to snap-fit a 32-inch DJ pole and a massive subwoofer into an airport ceiling tile.
It's a hilarious retail mix-up. for
Yeah.
sure. But if you look past the web copy error, the core specifications prove this is a deeply serious piece of hardware.
Yeah, like the sealed acoustic enclosure and that 6-year registered warranty.
Exactly. It's a highly adaptable piece of commercial infrastructure,
Yeah.
despite the website's identity crisis.
Totally. So we've broken down the acoustic mechanics and the plumbing behind commercial sound.
It really makes you appreciate the invisible engineering all around us.
It does. And here is something for you to mull over later. We usually think of architecture as just visual, steel, glass, paint.
But with technology like this, acoustic engineers are kind of dictating physical space, too.
Exactly. So the next time you are sitting in a crowded airport or a retail store and hear perfectly clear background music, look up.
Just look for those perfectly painted, snap-fit magnetic grills.
All right, and ask yourself, was the ceiling height, the layout of the tables, or even the physical shape of the room built specifically to accommodate the mathematical dispersion of those invisible speakers hiding right above you?